In Chapter 5, we're learning about quadratics, and one thing that a quadratic produces is parabolas. So what we're looking at are like x-intercepts, and that's the last thing we did in class is looked for x-intercepts. And we're going to have lots of different ways to find the x-intercepts. These are also called x-intercepts, are also called roots. They're also called solutions. They're also called zeros, but you kind of figured out the whole zeros thing when you used the zeros button on your calculator to find those x-intercepts. But there's 4 things that this could be called. So on example 1, when it says write an equation given the roots, then you know what you're given are the roots, the solutions, the x-intercepts, or the zeros. And so what you've been given is 1/2 and -5 as its roots. So we want to find the quadratic equation. So what we're going to do is plug in x minus 1/2 and then x minus -5 into 2 parentheses like this. And we're going to use FOIL to figure out our quadratic. This is just the standard thing that you'll do. X minus 1/2 times x plus 5 is what that turns out to be. And so we're going to FOIL this thing. And when we FOIL it and simplify it, we'll have our quadratic equation. So x times x is x squared. X times 5 is 5x. -1/2 times x is -1/2 x. And then -1/2 times 5 is -5 halves. Now, this is a quadratic that has some fractions in it, and I don't like fractions, so I want to get rid of those. And I'm going to do that by multiplying by the common denominator. Well, the 2 denominators I have are the 2 under here and the 2 under here. So my common denominator is 2. If I take a 2, that common denominator, and put it in the front and just distribute it, I'm going to get rid of the fractions. So that's what I'm going to do. 2 times x squared is 2x squared. 2 times 5x is plus 10x. 2 times 1/2 is 1. And 2 times -5 halves is -5. Now this is easy to simplify because I can see these are like terms, and so I'm going to have 2x squared plus 9x minus 5, and that is my quadratic equation. So you can get from the roots to the quadratic equation. You may want to pause this right now and just use this example to write the quadratic equation in the check your progress one. So if you'll pause it now and work that one and see how that works out, just do it exactly the same way, see what you get. Let's go to the zero product property. Basically what that says is for any real number a and b, if a times b equals 0, then either a equals 0 or b equals 0, or both a and b equal 0. So the example says if x plus 3 times x minus 5 equals 0, then x plus 3 equals 0 or x minus 5 equals 0. And we've done these, not necessarily in this context, but we've done these over time. And I want to go on to say that if this is the case, then x is going to equal -3 if I subtract 3 from both sides. And then if I add 5 to both sides, I'm also going to get that x equals 5. Well, to apply that to our parabola, if this thing were a parabola, which I know it is because it's a quadratic, then I would have roots, x-intercepts, or zeros at -3 and +5. So I know that I could draw basically a parabola with those 2 roots, or x-intercepts, or solutions. So that's what we're going to do here. We're going to start solving the quadratic equations by factoring, and what we're actually finding is the x-intercepts, or the roots, or the solutions. So let's start this by factoring this. I've got x squared minus 9x. This is a binomial, and I want to think GCF. What do they have in common? Well, they both have an x, so let's take it out. And what I have left in these two, when I factor out an x, is I have an x minus 9. So x times x minus 9 equals 0. Now we're going to separate those and say, well, in that case, if we use the zero product property, we're going to say x equals 0, or, and it could be and or, x minus 9 equals 0. If I add 9, then I find that x equals 9. So I've got these two answers, and these are my x-intercepts, or they're my solutions, and it's x equals 0 or x equals 9. So if I were going to draw a parabola, then I would have a x-intercept at 0, an x-intercept at 9, let's say, and my parabola could look just like this. So let's go on and do a little bit more factoring. This is why we need to be really good in factoring, because it just gives us so much information. This is a trinomial. When I think GCF, there is nothing that they have in common. And so I'm going to just start out doing your product and sum. The product is going to be 1 times negative 45. And the sum's going to always be that middle one, which is positive 4. So I need to go through and figure out what goes into 45. I know 1 and 45 does, 3 and 15, and 5 and 9, and that looks really promising right there, and I think that might be all. So 5 and 9 are actually 4 apart. So if I did 9 minus 5, that would give me a negative 45 when I multiplied it, and a 4 when I added it. So I know that this can just be factored into two parentheses. One would be x minus 5, and x plus 9 would be my other one. So my zero product property says that x minus 5 equals 0, or x plus 9 equals 0. So I just add 5 and add 5, and I get x equals 5. And I subtract 9 and subtract 9, and I get x equals negative 9. So these are my two solutions. They're my intercepts, and they're my zeros. So C. That one was pretty easy. C might be a little bit more challenging. One thing is I do not want this negative here. So with my x squared term, so the first thing I'm going to do is multiply by a negative 1. When I multiply all three things by negative 1, it's going to give me 3x squared plus 10x minus 8. The next thing I want to do is think about what can I factor out. And there's nothing that they have in common. So that's all I can do to that until I actually do my product and sum. My product on this one is going to be 3 times negative 8, which is negative 24. And my sum is going to be 10. So I need to find all these numbers that multiply to give me 24 and add to give me 10. So let's do the factors of 24. I have 1 and 24, I have 2 and 12, I have 3 and 8, and 4 and 6. And 4 and 6 looks pretty good. So, but I have to also think about this. 4 and 6 will add to give me 10. But two positives won't give me negative 24, and 2 negatives won't give me negative 10. So we're going to have to look at, oh, and if one was negative and one was positive, you get a 2. So let's look at 2 and 12. This one's kind of tricky. 2 and 12 will give me 10 if I subtract. So if I say like positive 12 minus 2, that would give me 10. So what I want to do, if you recall, is make this into a grouping problem. I do 3x squared. I'm going to go ahead and do the negative one first and the positive one second. And I'm actually just replacing my positive 10 with negative 2x and positive 12x. Then I'm going to group. My 3x squared minus 2x, they have an x in common, and that's it. So I'm taking out an x, and it's going to leave me with 3x minus 2. Plus, because of that plus right there, 12 and negative 8, they have a 4 in common. It always needs to be the biggest thing they have in common. And that's going to give me 3x minus 2, which that's really important that these parentheses are matching. And so I'm going to factor out my matching parentheses, which is going to leave me with x plus 4. So now my last step is going to be to do my zero product property, or x plus 4 equals 0. So I'm going to add 2, 3x equals 2, divide by 3, so x equals 2/3, or minus 4, x equals negative 4. So there are my solutions, my roots, my x-intercepts. So let's move on to this binomial right here. If I'm going to factor it, I want to think greatest common factor. I know that 2 goes into both of those because it's even, but actually 4 is the biggest thing that goes into both. So I'm going to take a 4 out. That gives me x squared minus 16 equals 0. So think about this. If I distributed my 4, I would get this again, which is what it needs to do. Once I got that, I've got perfect squares. My x squared is x times x. My 16 is 4 times 4. And then all I have to do is a plus and a minus in between. This 4, if I do the zero product property and I separate these, I get 4 equals 0, x plus 4 equals 0, and x minus 4 equals 0. So this one doesn't work because 4 doesn't equal 0, so it just doesn't work. So we don't use it. But these two we can use. We've got x equals negative 4 and x equals positive 4. So those are my two x-intercepts, my two roots or solutions. Okay, so this is the last one. It's E, and you can see there's a little bit of a technical difficulty here because I've already gone through it and I ended up having to get my calculator. So I'm going to erase part of it, but I'm going to leave part of it because I think part of it's going to be helpful. First thing I want to do is add my 7x and subtract my 6, and so add 7x minus 6, and I'm taking it to that side because it's just my 20 is positive, and that's what I need. So when I go to factor this thing, I need a negative 120 and a 7. So I did all the factors of 120, and I got down to 8 and 15. And if I say 15 minus 8, I'm going to get 7. And so I want to now factor this based on these two numbers. I'm going to go ahead and do my 20x squared here. I'm going to use my negative one first, but it doesn't matter which one. It's just easier, I think. And then I'm going to group this. I changed my 7x into negative 8x plus 15x. And then what I'm going to do is group these. And I get, I guess a 4 would be the thing that, a 4x would be the thing that gets 20x squared and 8x. So 4x comes out. That gives me 5x minus 2. And then between these, 15 and 6, 3 would come out. That's the one thing that they have in common. Now my parentheses are the same, so 5x minus 2 factors out, and 4x plus 3 factor is what's left. And so I'm going to set these by the zero product property equal to 0. And I'm going to find my, so 2/5 is one of my x-intercepts, and minus 3, 4x equals negative 3 divided by 4. Negative 3 fourths is the other one.